Okay, so bear with me on this presentation. It's going to be a bit of a longer one, but not as long as that we would be taking in time for class for this, because you can pause the video if you need to take time to write things down. I know this one has a lot more to write. It's a lot of information, but it's important information. So if you need to pause it, but this is just a much more efficient way than some of the time we're taking in class. So this is definitely one of those times where these videos come in handy. So we are going through today the different families or groups in the periodic table. So we know a group is the vertical column. So we have 18 different groups inside of the periodic table. And each of those groups has properties in common. That's why they're grouped together. They're grouped together based on how many electrons they have in their outer energy level. And they're based together because of that. It makes them so they're based together based on properties. So starting with group 1, so we're on the very left of the periodic table. These are called the alkali metals. It's all metals, and it only has one electron in the outer energy level, so that is why they are in group 1. They are very, very reactive. So this is the most reactive group that we have. So we will be looking at one of our very reactive metals in this group, sodium. In a couple of days or so, sometime within this chapter, we will be doing our demonstration to show how reactive they are. It is not the most reactive of this group. The further down you go in that group, the more reactive it gets. But we, based off those periodic trends, we did learn that with metals, as you go down the periodic table, it gets more reactive. But we will see sodium, which is not the least reactive either. So we definitely get something good to see. But for the most part, all those elements, they're soft, they're silvery and shiny, they have a low density. So we have lithium, sodium, potassium, rubidium, cesium, and francium. Those all make up our group 1 alkali metals. Our group 2 is called the alkaline earth metals. So don't get those mixed up. There is a difference. Again, this is all metals, and this time they have 2 electrons in their energy level. So when we start working with bonding, we'll talk more about some of the tricks we can learn. But if you notice right now, the group number and the number of electrons and the energy level, they are going hand in hand. So group 2 has 2 electrons. These are also very reactive, but they're less reactive than the alkali metals, which, again, we know that as you go further left with metals, it makes them more reactive. So we were to the right, so they're a little less reactive than that group 1. But they're also silvery. They have a slightly higher density than the alkali metals, and they include beryllium, magnesium, calcium, strontium, barium, and radium. All together because they're a bit of an odd group of elements. They don't quite follow some of the same pattern. So we call them the transition metals. And again, it's all metals, and they're either going to have 1 or 2 electrons in the outer energy level. So it's going to completely depend on which metal you're looking at, but they are going to, again, be slightly less reactive than the alkaline earth metals because they are further right on the periodic table. But because they're metals, they are shiny, they're good conductors, they have higher densities and higher melting points than group 1 and 2, so it takes more heat for them to melt. Examples of elements that are in this, iron, cobalt, nickel, silver, gold, those are all examples, but the properties are going to vary because they're not following quite the same trend as some of those independent groups we're talking about. All right, those bottom 2 groups on the periodic table there, they are called our lanthanides and actinides. So the lanthanides are shiny reactive metals, and that's our top row in that, our top period on there. And our actinides is the bottom row or the bottom period on that grouping down there, and those are radioactive and are made in laboratories. So they're not something we're finding in nature. They're something that we're creating in a lab, so they're synthetic. And we're going to be coloring these in on the next, or I guess I believe that would be Monday for you guys now, because they are due then, and we will be coloring in our periodic table with those to make sure we make sure we know where they are on there. All right, group number 13 is the boron group. So uh, this one, again, it has boron at the top, so hence the boron group. But this one has one metalloid and the rest are metals. They have 3 electrons in the outer level of their energy shells. They're pretty reactive, but not as reactive as the ones we've been talking about. They are solid at room temperature. And the 5 that are in that group are boron, aluminum, gallium, indium, and thallium. This one's got a wide variety of different elements. So we've got 1 nonmetal, 2 metalloids, and 2 metals. They have 4 electrons in their outer levels. Because of that 4, that means their reactivity is going to vary. It's not because the amount of electrons they have is really going to determine how reactive they are. So because it's right in this middle mark with a 4, it's going to depend on the situation in which element you're talking about, on how reactive it is. But they are all solids at room temperature, and it includes carbon, silicon, germanium, tin, lead, and ununquadium, which I believe might be one that now has a name on a more modern periodic table, so we'll have to do some looking into that. Group 15 is the nitrogen group. So we have 2 nonmetals, 2 metalloids, and 1 metal in this group. They have 5 electrons in the outer level. So again, because it's kind of in a halfway mark, the reactivity is going to vary. They are all solids at room temperature except for nitrogen, and that's a gas at room temperature. But the group includes nitrogen, phosphorus, arsenic, antimony, and bismuth. 3 nonmetals, 1 metalloid, and 1 metal. They have 6 electrons in the outer level. And now because we're getting close to having a full outer shell, this group is we're getting more reactive. So this group is fairly reactive. All of them, again, are solid at room temperature, but oxygen is a gas. So that's the one exception in there. We have oxygen, sulfur, selenium, tellurium, and polonium are all our examples of elements that are in group 16. Is our halogens. So these are all nonmetals. And they have 7 electrons in the outer level, so this makes them very reactive. This is our most reactive nonmetals. If you remember talking about periodic trends, we had our reactivity increasing as we went to the right for the nonmetals. So it's the opposite of the metals. So these are our most reactive. They are poor conductors because they're nonmetals, and they have very violent reactions with alkali metals. So group 1 and group 17 react together very violently. And when they do that, it forms salts, which is not the table salt that we eat. There's lots of different types of salts, but it forms some form of salt. Another thing about halogens is because they are so reactive, they are never found uncombined in nature. So, like chlorine is one of our halogens here. In nature, the chlorine gas exists as Cl2. So there's 2 atoms of chlorine combined at all times. So they want to react and bond so badly that they never exist by themselves. So examples here, we have fluorine, chlorine, bromine, iodine, and astatine. And our last group is the noble gases, and that is group 18 on the very right. This group contains nonmetals, and it's all nonmetals. And this one has a completely full outer shell of electrons. So again, when we get to talking about that, we'll realize how important that is. But that means they all have 8 electrons except for helium. It has 2. It's our exception. But they're completely full, which means they don't want to react because they're happy with what they've got. So they don't react with anything. They are all colorless, odorless gases, and it includes helium, neon, argon, krypton, xenon, and radon. Our exception here is hydrogen. So as we've definitely pointed out at some point, whether through notes or in class, hydrogen is way on the left in group 1, even though it's a non-metal. And all of our metals are on the left side. So hydrogen only has 1 electron in the outer level. It only has 1 electron ever. So because of that, it is super reactive because it can only have 2 to begin with, and because it has 1, it only needs 1 more to react. So it makes it super reactive. So that's why it's in group 1. It has things in common with group 1. The 1 electron, and that makes it want to react with things. But ways it is different is that it is colorless, it's an odorless gas, it's not a solid, but it does have a low density and it's really explosive reactions, particularly with oxygen. So that's why there's electron similarities and the reactivity are similar, but a lot of those properties are different, but that's why we put it in that group 1 over there.